sample is more than if sample is more than 30, we usually go for Z test. And if sample is less than 30, we usually prefer T test. And with known variants, with unknown variants, what sort of formula that we have to see, we have already seen in the last sessions. So I'm just giving parametric tests are these things. Like if it is one sample, we use simple T test. If it is two dependent samples, so paired sample, if you're trying to find out before and after effect, so we use, if it is a parametric test, we use paired sample t-test. If it is two independent samples, so two different samples we are trying to find out. So in that case, we go for unpaired sample t-test. And if it is more than two independent samples, so different samples, we go for ANOVA. And correlation will be found out using Pearson correlation. So this is about parametric tests. Once, as we have already seen these things, suppose if data is not normal, data is not normal, so then ideally we will not check the aspect of mean, we go for median, because if median will be least affected either with a non-normality as well as outliers. So we prefer median. So under such circumstances, we go for Wilcoxon test if it is for one sample. If it is two dependent samples, so paired, for substitution of paired t-test, we go for Wilcoxon test. And for unpaired sample t-test, we go for Mann-Whitney U-test. And for ANOVA, the replacement in non-parametric test is Kruskal-Wallis test. And correlation, we usually find out with Spearman correlation in terms of non-parametric. Okay. So most of the people will use these and that, but ideally as a researcher, we have to use only these things. And in the last class, we have seen chi-square analysis. So which if there are two categorical items, so then we use this formula to find out that one. So chi-square and rank correlation coefficient is already done. So I'm not touching that point. And so Mann-Whitney U-test. So as we have already seen, so this will be used for as a substitute for unpaired t-test and paired t-test. Okay, and he is the person who has given that Wilcoxon test. So some additions has been done by Mann-Whitney. So that's why it is called as Mann-Whitney U-test, or Wilcoxon rank sum test, or Wilcoxon Mann-Whitney test. Okay, sometimes this is also called as Wilcoxon t-test, because t-test is a parametric test. And if the parametric, like if the normality is not assumed, then we go for Wilcoxon t-test. And there are certain assumptions that quite similar to earlier thing. And here, so you have to select the two independent data samples. So can anyone just tell what do you mean by independent samples? Two independent samples? Because this is the term which we'll be using, and I feel the student, like the learners are going to take some exam. So even in that case, definitely this will be question, and the questions will not be straight question something, and it is going to be an open book system like that. You can use your Excel or some kind of material also, but you have to think and answer like what exactly is going to be scenario. So under such circumstances, definitely you should be thorough with like what is an independent sample or something like that. What do you mean by two independent samples?
Which are not related, sir.
Okay. Can you take any example? Any example of your own?
Suppose we are assessing two variables like height and performance.
Sir, could I say?
Yeah,
Hello?
please. Yeah.
So, for Mann-Whitney U-test, taking two independent samples would be, suppose if we are checking same variable in two genders, like males and females, or if we are suppose checking intelligence in two or three sections, A, B, C.
Fine. Yeah, right. because as initially how told, two genders, so male female, so male cannot impact female and female cannot impact, so this is a separate group and this is a separate group. If you are dealing two separate groups like that, so then we call it as two independent samples. Okay, and in this case, let n1 is number of samples of first category and n2 is sample of second category, male and female. We have to identify that, and we have to combine two data sets, and we have to rank by allotting rank 1 to the least value, and maximum will get the high rank. Okay, and if there is a tie in the values, we can take average rank of those two observations. Ideally, even in rank correlation also, we do like that only. So then we have to define the null hypothesis and alternate hypothesis, right? And then we have to find out some of ranks for sample 1, because we have already identified what is ranks given for this particular sample and what are the ranks given for this particular sample. So then we have to add these ranks separately and these ranks separately. So group 1 ranks separately, group 2 ranks separately. So that is what you can see here. And sums being T1 for sample 1, that is total 1 for sample 1, and T2 for sample 2, total 2 for sample 2. Then we have to find out these statistics values. So U1 is equal to sum of first ranks minus N1 is sample of sample size of first sample into N1 plus 1 divided by 2. And U2, this is completely for sample 2. So T2 is sum of ranks of second sample minus sample of second sample size of second sample into N2 plus 1 divided by 2. So once we get U1, U2 values, you have to find out minimum between these two values. Okay, as you're trying to find out the difference in either medians in these two groups. So that is what this Mann-Whitney test using sum of ranks. So that's why it is called as rank sum test also. Okay, and for finding the critical value, there is a table for N1 and N2. I have already shared that table. You can just go through that table. The difference comes in the rejection criteria, because usually we will be rejecting the null hypothesis. Suppose since this is a not normal curve, I'm checking a chi-square here. Usually we'll be rejecting if suppose if calculated value, if the table value is 2.2, and if we get the calculated value is 3.3, then we would be rejecting ideally. I hope you remember this, right? But in this case, reject the null hypothesis if calculated test statistic value is less than critical value. So we'll be just seeing the reverse of the usual thing. So that is the difference. Is that clear? Ideally, we'll be reject if if calculated value is 2.3 and table value is 2.2, we will be rejecting the null hypothesis in the case of parametric test and chi-square. But especially in Mann-Whitney U test, we'll do in a reverse manner. Okay, if test statistic value, the calculated value U is less than critical value, then we'll be rejecting the null hypothesis. Okay. Once we see a problem, probably we'll be able to understand. The theoretical part, is that fine? If that is fine. Okay, so now you see there is a company which wanted to check the two brands. So there are two brands giving them the same revenue in 8 zones. So they have got 8 zones and they wanted to check which brand is doing. The brand A, brand B, brand 1, brand 2. Is there any difference in the medians of that brands or not? Okay, so for that, and when you're, if in this case, in this question, you will not be able to identify that is normal or not normal, but you can just do a mean median mode test, and if these three are different, then we can call it as a not normal thing. I've already calculated this, and these have given not normality thing. Okay, and so there are 8 zones, zone 1, 2, 3, 4, and revenue given by the first brand is 38.9 and the second brand is 47.8. Okay, we cannot simply tell as there is a huge difference here. Okay, because there is a gap between these two things, brand 1 and brand 2 in terms of revenue. If you take zone 2 here, that is 31.2 and this is 60. Again, there is a huge difference. And third, it is 43.3, 63.8, something like that. Now you see, by seeing that, you should be able to identify, are we talking about paired sample or independent samples? Is it a paired sample or independent sample?
Independent.
Because you're
Because
talking about two brands, two separate brands in different zones. Okay. There are 8 zones in both the brands, N1 and N2. In this case, assume that there are certain scenarios where zone 9 is also can be included and you can get data only from brand 2. So that is also is acceptable. Okay. So that's why, but in this case, it is straight away same thing. But since it is independent samples, you can have different sample sizes also. Okay. But here, since it's a problem, I've just given this one. But the sheet which I've shared with you has got different samples also. Okay. And N1 is 8, N2 is 8, N1 plus N2 is, which is equal to N, that is 16. Now, ideally, we will be defining null hypothesis as there is no difference in the median values of brand 1 and brand 2. So this is what we usually take because we just wanted to see is there any difference in the medians or not. Okay. And alternative hypothesis will be definitely telling that there is a significance. Okay. This is what we have seen in parametric test and even in non-parametric test, we'll be just taking. Only difference comes in they will be using mean, we are using median. Okay. So coming to this one, as we will be just taking the ranks. Okay. So, and as I told, out of this total observations, which one is the least value? So 21.8 is the least value. So in zone 4 of brand 1. So it has got rank 1. Okay. In the procedure which I have shown earlier, the least value will be getting the simple rank, okay, the first rank. And the next least value is 31.2, which has got a rank as 2. Next least is 38.9, which has got rank as 3. So the next least value is 43.3, which is 4. Okay, whose rank is 4. Next least rank is 47. So here you are combining both the brands and giving ranks according to that position. Okay, so this will give rank 5. Okay, so next rank is 48.4. So this has got rank 6 here. Next is 48.8, so which has become rank 7. So like that, ranks will be given. Is that clear? Are you able to follow? Because we have to combine both the values and then we have to start giving ranks and see that the least value will be getting first rank, second rank, something like that. Okay. And we have already seen there are totally 16 numbers. And which has got 16th rank. So 16th rank is this. That shows this is the highest value among these observations. Okay. So like that we have given. Sorry?
Together we have to take it and
Yeah,
then
together we have to take, but we have to give according to the position of the brand. Okay, so brand 1, brand 2 separately, we have to rank according to the placement. We are not supposed to change that one, right?
Sir, one question.
Yeah.
In case of unequal, number of items for two brands, so
Yes.
what kind of rank we will give? According to that only we will give the
Yes.
rank, and for the other one there will be no rank, right?
No, here we suppose assume that there is zone 9
Yes, sir.
is also there, which we are not able to get brand 1 data, but this is something 93. So assume that. Okay. So this will become 17th rank. And assume that there is zone 10 is also there, whose value is 93.8. So which will be getting 18th rank. Here will not get any rank in these two places. Okay, because whatever the data is there, we'll leave rank according to that value and according to that position. That's what. Fine. Is that fine or not? The person who asked that question, is that fine or not? Can I just
Yes,
move
sir.
ahead?
Yes, sir. Yes, sir.
Right.
Understood.
Okay, so like that, you can just go for unequal sizes also, because this is an equal size, so where you got. Otherwise, you'll be getting this sort of things also. And I believe I've shared one problem like this thing, like this sort of different zones. Right now, after that, you have to add all these things. Okay, so if you add 3 plus 2 plus 4 plus 1 plus 11 plus 13 plus something, and 5 plus 8 plus all this summation will be equal to 47 and 89. Okay, I have already mentioned you have to find out u1 and u2. So u1 is T1 sum of ranks of first sample minus N1 into N1 plus 1. So we know that sum of T1 is 47. Just now we have calculated 47 minus number of observations are 8 into 8 plus 1 divided by 2. So this has given a value of 11. Okay, coming to the calculation of U2, sum of ranks of second sample minus N2 into N plus 1. So T2 is 89 that we have calculated. 8 into 8 plus 1 divided by 2. So that is 53. So we have calculated U1 and U2. Suppose if you have 10, if N2 value is 10, or if N2 value is 9 or something, so you'll be using 9 into 9 plus 1 divided by 2, or 10 into 10 plus 1 divided by 2, like that. Okay. Now we have to find out minimum value of between these two. Okay. So minimum of 11 and 53 is definitely 11. So this is what the test statistic or calculated value. And if you see the table value, the critical value of N1 and N2, it is 13. As I have shared the table values, I hope you will be just identify that one. And in the table values, you will be just getting N1 values 1, 2, 3, 4, 5, something like that. And N2 values column wise 1, 2, 3, 4, 5, 6, like that. As N1 and N2 are 8 and 8, you have to just identify where exactly 8 is coming, where exactly 8 is coming. And this value is considered as the table value. Okay. So that is what N1 and N2. So you can just see the table which I have shared with you. So this contains the value like that. Okay. And according to that, the calculated value is 13. So as so table value is 13, and as calculated value is like this 11 is less than 13, we are rejecting the null hypothesis. That means there is a significant difference in the median values of the brand of the sales of brands 1 and 2. So this is how Mann-Whitney U-test will be done. Is that clear? Is that fine, or any doubt?
Yes, sir. Sir, in
Yeah.
this problem, since it is, sir, could you please show the question slides, sir?
A company wanted to check whether their two brands are giving them the same revenue in the 8 zones in which they are operating. So there are 8 zones. They wanted to check whether these two are giving same revenue, or is there any difference in the revenues.
Okay. Sir, similar questions are there with Spearman row also, sir.
Yes.
So what is the difference between using a Spearman row and then this? In Spearman row, we generally see the correlation, means how both of them are related.
Yes.
Yes. And
Yes.
in this we are trying to find out how they are different. Is it
Yes.
that?
In Spearman rank correlation, you're trying to check two groups of people. Okay. So in the last example which you have shown, so there are nutritionists, they have given ranks for different items. Items will be taken item 1, item 2, item 3, something like that. And nutritionist group has given certain ranks for these items. Okay. And housewives have given certain values, certain ranks for this one. We have checked whether these two groups people are giving similar kind of ranks, or is there any deviation in the ranks. Okay. We are trying to check two groups of people and how they have ranked, and are there any correlation between the ranking pattern or not. In this case, you're trying to compare two different brands, either revenue or something like that. Fine. So in the earlier case, we use it to check what is the ranking pattern and is there any correlation between that ranking pattern or not. But in this case, you are trying to see is there any difference in the median values of these two groups or not. Okay.
Yes.
Fine. Okay. So next is Wilcoxon signed rank test. So this is for a paired sample. So since it is a class, I've just separated in the heading itself like a paired sample. But in exam or in any test, probably we might not be given such kind of thing. Okay. If any doubt, you can ask me, otherwise no problem. So here in the question you can see that suppose a drug has been checked for its impact on blood pressure. Okay, a medical practitioner has launched a new drug and they claim that it reduces the blood pressure of people, and 10 patients have been identified and their blood pressures before taking the drug and after taking the drug has been tabulated. By seeing this sort of question, you should be able to pick that it is a paired sample test. Okay, so maybe paired t-test or Wilcoxon signed rank test, depending upon the normality of the data. If in the question they have mentioned normal, you have to go for paired t-test. If in the question they have mentioned that normality is not accepted with the data, then you have to go for Wilcoxon signed rank test. Clear? It is straight substitute for a paired sample t-test of normality. Okay.
Yes,
because you're trying to compare same sample before and after. Okay, weight reduction or error reduction, previous, after, something like that. Now we have to check at 5% significance level, and most of the times, like almost all cases, have taken 5%, and you can give a try with 1% and 10% also. Okay, because there are chances like where if the significance level is changed, probably the acception rejection region might get changed. Now there are 10 patients, so 10 patients before and after, so they have taken. Now if you see, after taking, the blood pressure of 172 guy has become 132. After taking the pill or medicine, 163 patient has become 123. So in most of the cases, I think there is a reduction. We can just have some kind of conclusion also here, but anyhow, we'll just go with the procedure. So Wilcoxon signed rank procedure will take some kind of sign. The name itself tells about the sign. Is it a positive sign or negative sign? Okay. The given data is of two time frames. First one is before taking the medicine, after taking the second data is after taking medicine. So it is a paired test. Okay, so a paired sample, and N is 10, because here you cannot have a P11 which will be having data as 130 here, which will not be having data like that. Okay, so if it is a paid sample, definitely you should get same number of samples before and after. Otherwise, you will not be able to compare. Okay, and here null hypothesis is simply the mean difference before and after drug is 0, because this even in t-test we have seen that null hypothesis tells like the average difference or mean difference is equal to 0. And an alternative hypothesis, they tell that mean difference is not equal to 0. So there we have taken mean difference or average difference. But here we are taking median value of blood pressure before and after is not equal. Is that clear? Fine.
Yes, sir.
So now you are just taking that one. So you have calculated the difference. So this minus this, this minus this, this minus this minus this, like that. Okay, and you've got all the differences. Okay, since you're trying to find out before and after value, so probably you can find and we cannot give a negative values for ranking. So what you have done is you have made it as absolute difference, okay? Or else what you can do is you can make this minus this also. So in that case, you'll be getting some value, but finally you have got certain values, okay? So now it is 41, 40, 20, 18, 4, 29, like that. And this also follows similar pattern like Mann-Whitney U-test, because so Mann-Whitney in the earlier case, they did not consider the sign, but here we are trying to find out that sign with the help of paired sample. Okay. And even in this case, the least value will get the first rank. Okay. And next least difference value will get second rank. Next least value will get third rank. So like that, it has got something. Right. Fine. I've just ranked based on the numbers. Okay. And here we have to just find out the positive ranks and negative ranks according to the problem. So according to the problem, how many positive ranks are there? So this is a negative value. So I did not get any rank here. This is a negative value. This is a negative value. In all these cases, we got negative values only. So number of positive ranks have become completely zero. Okay. Suppose assume that in one of the cases, this is 128 and this is 110. Okay. So assume that this is 140 or something. So this is 110 and this is 128. So in that case, what it is going to be? It is plus 18. So this is going to be here you'll be getting a value called as 4. Here you'll not get any value. Is that clear? In this case, fortunately,
Yes,
we have got all one negative things only. Okay, so if we just deduct this 132 minus 173 is minus 41, something like that. Suppose if this is 110, patient 4, earlier it is 110, and after using that pill, the medicine, assume that his deep blood pressure got increased. So in that case, it is going to be a plus 18. And so that plus 18 will get a positive rank, which is numbered as 4, and you will not get any rank here. So if you add all these things, we'll be getting only 4 here. And as this, I have deducted this 4, it is going to be 51. So that is what this Wilcoxon signed rank test, positive ranks and negative ranks. Is that clear? So next, we have to just find out the positive ranks. But according to the problem, we got all positive ranks as sum of all positive ranks as 0 and all negative ranks as 55. So for taking an example, I've just made this as 4 and this as 0. That's why I got some other value. Now we have to find out minimum between these two. Okay, 0 and 55. What is the minimum between these two? Obviously, it is 0. So level of significance is 0.05. So since we are trying to check whether the median values are less than the before, then this will become one-tailed test. I hope you remember, if you're trying to find out if it is not equal to, then it will become a two-tailed test. Okay, either for normal or not normal. If you're trying to find out less than 0, so less than some value or greater than some value, so then this will become either right test or left test. Is that clear? So this will become like that. Is that fine?
yes, sir.
So this is a one-tail test, and if you just have any doubt, you can just go back to the earlier class video so that you will get some kind of pay rate here. And according to the table, for n, it is the table value is 11. So in the last case, we have seen in the last slide also, we have seen that if calculated value is less than this table value, we will be rejecting the null hypothesis. Okay, so this is what the difference in normal tests rejection and Mann-Whitney tests. So, okay, in both the cases, if calculated value is coming to be less than this table value, we will be rejecting. Only difference is quite opposite. Okay, fine. This is how we'll be checking the paired samples using Wilcoxon signed rank test. If it is okay, I'm going to the next test. Is that okay?
Yes, sir.
Fine. And the last test is cruise.
Interpretation once again, sir.
Yeah, one. Okay. So interpretation is usually in normality tests or tilde chi-square, if at all, we will be having a critical value. So critical value is also called as stable value. Okay. Table value is, assume it is 11 and our calculated value is 0 or 4, 5. So from 0 to 1, 0 to 11. If at all our critical value is 0 to 11, ideally we will feel that that falls in this zone and this is the rejection zone. If it is a normality test or tilde chi-square. But only in the case of Wilcoxon signed rank test and Mann-Whitney U test, if calculated value falls in this value, we will reject the null hypothesis. Okay, we will take a reverse of the normal tests. Okay, that is the difference. And since our calculated value has become 0 and table value is 11, okay, we have rejected the null hypothesis. That means there is a significant difference, especially there is a decrease in the blood pressure of the samples after using that medicine. Okay, fine. Okay. Next, last test is Kruskal-Wallis test. Okay, this is a substitute for ANOVA. In the last class, if you remember, we have seen four salesmen or four sales group A, B, C, D. If there is more than two groups, ideally the Z test and T test will not fulfill the requirement of testing the means or comparison of means. So we have taken ANOVA, analysis of variance by comparing. We have calculated F value, which is mean square between divided by mean square within. Okay, because we assume that, so these four values, these four groups have assumed the normality assumption. Suppose if normality assumption is deviated, then you cannot use ANOVA. In such circumstances, we'll be using Kruskal-Wallis test. Okay, so here you are just trying to find out values of different groups, maybe 3 groups, 4 groups, 5 groups, something like that. Okay, so what you have to do is gather the data from different groups. Okay, so N1 is sample size 1, N2 is sample size 2, N3 up to so on, and combine all the groups and rank the observations by allotting rank 1 to the least value. People just remember whatever Wilcoxon sample test and Wilcoxon signed rank test you follows, the same pattern will be followed here. Only difference is they'll be you finding that H statistics, which seems to be quite bigger. But once you understood the concept, definitely it's going to be very easy. Okay, so here also you'll be trying to rank the observations according to the value. Later we'll be using in this particular equation. Okay, if H statistic, and here again you are going to use your chi-square table. Okay, so chi-square table to find out that value. And here also you follow normal thing. If calculated value is less than significance, we will accept the null hypothesis. Only in the case of Mann-Whitney U test and Wilcoxon signed rank test, we'll follow a reverse pattern. Apart from that, all the observations, all the other tests will follow normal thing only. Okay, so suppose this is quite the procedure is quite simple as the Mann-Whitney U test only, so that's why I'm not spending some time on that. And Kruskal-Wallis test is, suppose a company opened 4 stores in 4 different locations. Obviously, they wanted to check how they are performing. Is there any difference in the performance, or they are going alike or something? So for that, since this data, the data which I have taken is not following the normality, so normality principle is violated in this case, and they have identified sales from different stores. Sales from store 1 in 6 days is like this. Sales from store 2 from 6 days like this. Is like this. Sales from store 3, sales from store 4. Now you have to, if it is only 2 assume that if it is a 2 sample, which test will be used? Assume that we don't have this sales store number 3 and 4. Which test should be used? If normality assumption is not accepted, then
Sir, for only two groups, men with me.
Exactly. So that is the thing. If it is two tests, if it is only two sample, definitely you can go for man Whitney. Assume that you're trying to find out any change in the stores. Okay. And so this is stores, sales in the store one before training, and this is sales in the store one after training. So assume that you're trying to compare same group before and after some treatment. Okay, so then which test should be used?
Wilcoxon sign rank test we will use then.
Exactly. Okay, so just follow these things, and if you find any textbook, just try to think like what is the test which should be used. Because even in the exam which you are going to appear, I've given some kind of tricky questions like that only. So as I told, this can be an open book exam. You are free to use anything, but only thing is you have to find out the exact answer. Okay, suppose if this sort of question is there, you should be in a position to answer. Okay, so but since it is a crucial valence test, it is definitely for multiple group comparisons. Okay, number of stores are 4. You have to find out total n, which is going to be n1 plus n2 plus n3 plus n4. Even in this case, there might be some kind of seventh observation which is not here, which is not here, which is here, which is here, or which is here, which is not here. So such kind of things can happen in this case. That's why we have to take separately n1, n2, n3, n4. And ideally, null hypothesis, I think by this time you should be thorough with the definition of null hypothesis. Null hypothesis simply feels that there is no difference in the performance. There is no difference in mean. There is no difference in median. But alternative hypothesis, so as a researcher, we would try to prove something. Okay, if there is no effect, there is no need of any research, right? Usually there is something called as 4G sims, 5G sims, and with 5G sims you will be trying to tell that this performs better than 4G. For that, that will be defined usually in alternative hypothesis only. In null hypothesis, we simply define that 4G sims and 5G sims work alike. There is no difference in the performance of 4G and 5G. But in alternative hypothesis only, we tell that either more than performance or less than performance, like that. Okay. So even the crucial values test, the ranks are straight away taken because the least value will be getting the first rank, next rank, something like that. If you just go like that, if we will be getting. So in this case, if you see the least value is observed in store number 3. Next least is observed in same store. Next least is observed in same store. Okay, similar thing. So that's why if you see ranks, the first rank is here, second rank is here, third rank is here, fourth rank is here. By seeing that, you can obviously tell that maximum, the minimum ranks are coming here. So then definitely there might be a problem of difference in the performances of that one. Okay, and you see this store one which has recorded almost out of 24. So 24 is the sample size, and 24 rank is here, 23 rank is here. That means top 2 ranks are here only, as per this value. Okay, only 22 is coming to here. If you try to rank the stores according to that value is given and add those values, as I told, this is just an extension for the Mann-Whitney U-test. Okay, so now we'll be calculating the H value. So H value is 12 divided by n into n plus 1 sigma Ri square divided by Ni minus 3 into n plus 1. So we know that n value is 24 and n plus 1 is 24 plus 1 multiplied by R1 square divided by N1, R2 square divided by N2, R3 square divided by N3, R4 square divided by N4. That means what is the rank of first total score? 118. You can see that 118 is shown here. Rank store 2 rank is 77, the sum of that one. So that has been shown here. And rank 3 store. So rank 3 store 3 ranks is 37. So that has been taken as 37 square. Store 4 ranks, sum is taken as 68 square. And since this is all the stores have got only 6 observations, it is begins 6, 6, 6. Suppose you have 7 observations, you will be just maintaining dividing 7 and 7 in these two cases. Okay, so that is how you'll be taking. Under such circumstances, 6 plus 6 plus 7 plus 7 will become 26. So this will become 26 and this will become 26 and this also will become 26. Okay, so the calculated value has come as 11.153. Okay, is that fine? Only simple thing is the value has got the formula seems to be quite bigger, but it is very easy concept. In fact, Kruskal values is considered to be one of the easiest tests according to me. Okay, only thing is you need practice. That's what. Is that fine, people?
Yes, sir.
Okay, so next is we have 4 groups. So degree of freedom is going to be that k minus 1, it is 3. And we have to just find out at 0.05 significance level, degree of freedom 3, the calculated value, the table value of chi-square value is going to be 7.815. As the calculated value is more than our table value or critical value, what will we do? This is usually that happens. Okay,
Reject null
calculated value is 7.815 and sorry, this is table value and our calculated value has fallen 11 point something. Okay, this is completely rejection region. If it even if it is 7.82, 83, 84, it should be rejected. We fail to accept the null hypothesis and there is a significant difference in the performance of 4 stores in terms of sales. Okay, so only change of rejection acception will be there in the case of Mann-Whitney test and Wilcoxon sign rank test. Apart from that, we are going to be using the same thing, right? Fine. So this is what, and sign test, it is going to be almost similar to the earlier case, and I've just used one more example. So before and after, okay. There is a traffic station and they just wanted to identify, is there any change in the number of accidents at different signals because of implementation? So it is going to be some kind of similar for a paired sample test. Okay, so difference is plus and minus, and since you are going to use only samples of one thing, so where you are going to use a p bar. So this is test of proportions. Okay, so how many pluses are there, how many minuses are there? So as there are totally 12 observations, so 12 observations, how many minuses are there? Only 2 minuses are there. Okay, so in all the rest of the cases there is a plus. Okay, that means the difference is observed. And if you see total number of positive signs, these are favorable outcomes. Okay, because you're trying to decrease the number of accidents, so we call it as in terms of proportions. So it is 10 divided by 12, so that is p bar, and 2 divided by 12 is going to be q bar. Okay, we have to check that normality thing by multiplying n into p bar and n into q bar. So if you see, if any value is coming to be less than if between these two values, if any value is coming less than 5, then we use this binomial approach, approximation method. And if you just see the binomial table, we'll get the probability of as 0.0192. As you are trying to test at 0.05, which is less than the critical value, we fail to accept null hypothesis. That means there is a significant change in the accidents due to new traffic system. And in this case, I could not able to provide binomial table because it is a very big thing and I could not get that one. Only the table I did not provide. If at all, I'll check, is there any PDF available tomorrow so that I'll be able to send this one. Okay. So this is just a test for proportions instead of that medians. Okay. I think with this, I'm done with my session. Any doubts? And in Excel sheets, which I'll be Excel sheet which I have shared with you, which will contain all these things, right? Okay, so that is from my side. Any doubt? The concepts which you have seen today?
Sir,
Or
not today's thing, sir.
okay,
Before one, sir.
that is the differentiation between mean, median, mode, exact value, right?
No, sir. On moments, sir.
Okay, so moments. Like, so what is that moments related
Sir,
thing?
actually, you have given about skewness a formula, sir, with beta. Beta
Okay.
1 equals to mu 3 square by mu 2 square.
Yeah. Mood. Yes.
And
Yes.
then you have talked about moments. Then you have given formulas for moments.
1 minute. Yes. I'm just sharing that one. No, it is. I think it is in module 2, right?
I think so, sir.
Yes, moments.
Yes, this one, sir.
Yeah.
Sir, if we will calculate the skewness with this formula, this should match with beta also, sir. Na? But that is not coming, sir.
Yes, because if you see, measurement of this has been given by many people. Okay, so we have got some Pearson coefficient for skewness, Pauli coefficient, Kelly's coefficient, and beta. So we will be having a lot of things. That's why that will not be exactly matched, but we'll be getting positive, negative, similar to that one.
Okay. And
Okay.
second
We
question
will,
is, sir,
yeah.
when we
Yeah.
calculate with this formula, we'll get one number. Yes?
Yes.
So
Yes.
how will we interpret this number with the skewness? How will we define it, sir?
Fine. Suppose if you calculate any of these values, assume that you got minus 2.3 or minus 0.5. This shows that the data is negatively skewed. Okay, so that shows that negatively skewed, where mode is more than median is more than mean. Okay, that means maximum number of people are falling into a particular value. That is what mode represents. Okay, and if you calculate something and if you get a value as plus 2.7 or plus 0.8 some value, it tells that the data is positively skewed where mean is greater than median is greater than mode. Okay, so maximum people are falling down and only one variable is dragging the total thing. And especially if you take the Indian economy or scenario something, 80% of the wealth is concentrated with only 20% of the people. Okay, maximum people have got only 20% of the worth, and only 20% of the people like Ambani or some kind of Adani. So these are the people who holds 80% of the worth. Okay, so that is where mean is skewed. Like, so mean will be easily influenced because of an outlier, and especially positive skewness is like that. Okay. And if skewness is 0 or nearly 0, then there is no deviation in mean, median, mode, something somewhat nearer. That's the thing.
So we can use both the things depending on the what situation.
Yes, depending upon the value, we have to ascertain whether it is positively skewed, negatively skewed like that. If it is negatively skewed, mode will be more. If it is positively skewed, mean will be more. That's the thing, right?
Okay.
Okay, fine. So anything else? If at all anything else, definitely you can get back to Farah ma'am or me. So
Yes,
I'll
sir. I have many things which I'll put it up.
definitely. Even I feel I'm a learner and I'm learning many things, and the doubts which you people are raising, definitely it is making me to learn more. So thanks a lot for that. And If for time being, if we are okay with the doubts, I can conclude that.
Yes, sir.
Fine. So thank you, and
Sir, your PPT is excellent.
so thank you very much, sir.
Yeah, I like it very much. I cannot understand how do you manage this type of PPT. Oh, beautiful.
Thanks a lot, sir.
And
Thank you,
your
sir.
way of presentation, excellent.
Oh, thank you very
We
much,
are
sir.
learning. We are learning.
Sir, I'm learning with your valuable guidance, sir.
So now I am requesting Farah, please show the respect to Professor Naresh Babu.
Sure, sir, sure. Sir, I want to share. Yeah,
Yeah,
okay.
please, ma'am, please.
Okay.
Today all the students are there. You can take one photo
Yes,
with Naresh
sir.
Babu.
Yes, sir, sure. Good evening, sir. Good evening, everybody. So, we want to express our sincere gratitude to Dr. Naresh Babu for their remarkable teaching. So you have a unique gift for simplifying complex concepts with everyday examples. Your encouragement of interaction and the open forum for questions at the end of each class has been invaluable. And your willingness to address the students' queries and ensure that they fully understand the material has been a key factor in their academic success. Thank you once again, sir, for your exceptional and friendly teaching, sir. Thank you so much. And so, if you're comfortable, then we can take one picture with everyone.
Yes, ma'am. Yes, ma'am.
Yeah.
And I would
So,
like to thank Farah ma'am for coordinating, because I got stuck up with many works, and she patiently called me every day, and she keep on posting that, and she has apologized many times, and ideally that should be from my side. But thanks a lot for being patient, and I would like to thank Datta sir for giving me this valuable opportunity to learn and share my knowledge. Thanks a lot, sir.
Thank you, sir. Now
And
I am
all-
requesting all the students, please open your video so that we can take one photo. Farah, please you stop share. We can take photo with sir.
and students, you want to add anything in this? Like, do you want to say anything about Naresh Babu? So you can also share your opinions.
Thank you, sir, for simplifying the concept very well. And yes, it was an in-depth exploration into statistics. It was really very good. Nice journey, sir.
Thank you, ma'am.
Farah, you are not visible.
And so my network is not. It's not that good.
Okay. So, Dr. Nimrat, do you like to add something?
Sir, I haven't been very regular, but I can just say one thing, that I agree with all of them. You have a really a very simplistic way of expressing. So my pranam to you, really very good. I
Thanks
learned a
ma'am.
lot in the
Thanks a lot.
teaching, in the way you taught. Thank you so much, sir.
Yeah, thank you very much, ma'am. Thank you. Thanks a lot.
Mona Lisa, I am requesting you to say a few words.
Sir, teaching process is very good. Slides are very good. We learned lot many knowledge from sir's session. I enjoyed sir's session.
Okay.
Thank you, ma'am.
Thank you, sir.
Thank you.
So, Farah, are you saying something?
No, sir, I'm not saying anything. So we will miss you for sure, sir. And please, sir, you're always welcome in RPRIT.
Definitely, ma'am. Definitely. So thanks a lot, ma'am, for continuous support, ma'am. Thanks a lot.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Good night, sir. Good night.
Good night.
Thank you all. Thank you for being patient. Thank you.